A very good evening to all members present here. So today we are in another different topic, 3D printing, important significant role in mechanical engineering. So in this presentation, we are going to see the basic fundamentals of 3D printing, comparison between conventional methodology and the 3D printing, or prototype development in integrated product design and manufacturing. So this and all we are going to see as a comparison, the trade-off matrix, and the corresponding advantage of using 3D printing in, in modern technological revolution, and what are the challenges faced in 3D printing technology, and what are the latest trend available in 3D printing technology. So these things we are going to see in nutshell. So before moving to the topic introduction, let us describe the session objectives. So 3D printing technology in mechanical engineering particularly attempts to modify the design of the product as well as the prototype and manufacturing process. So this 3D printing can be otherwise called as rapid prototyping. So with the help of the tool, we can able to enhance the design structure as well as the prototype development as well as the final manufacturing process. So by rapid prototyping method, we can able to construct more flexibly complex geometrical structure and more customized efficient production. At last, we can able to go for a quick short span of model or prototype development with better innovative solutions. Using 3D printing, very quickly we can able to construct a prototype of a final model with using cheap materials and at a reduced cost. So this is the main thing to be followed in 3D printing technology. Now let us see what is meant by 3D printing in mechanical engineering. So using 3D printing technology, most of the companies can able to shorten their product build-up time as well as the product launching time to market by reducing the material removal and as well as the inventory cost so that companies can enjoy better design flexibility. 3D printing in mechanical engineering not only helps to optimize the product design, it enables the part to be produced with utmost complex geometries, either that can be external or internal structure of the part. Whereas the conventional methods, it is too difficult to create. So that's why we are going for 3D printing. So we can significantly save some amount of material wastage, and that increases the operational efficiency of uh, the prototype model. So what are the advantages of 3D printing in mechanical engineering? So reduced development time, that is model or prototype development time. The 3D printing enables the digital design, that is a CAD file as an input source file. So that has to be converted quickly into a physical prototype. So this significantly speeds up the iterative design process. So when and there the changes can be implemented and tested quickly, that leads to have a significant reduction in product development cycle. So if any further changes, if you want to update, so that can be immediately implemented and further testing can be carried out. So without compromising with the product development life cycle time. The next one is complexity with additional cost. So one of the greatest strength of 3D printing technology in mechanical engineering, ability to realize high complex geometries and structure, even that could not be made possible by traditional manufacturing methods. But one thing is, due to the complexity of the part, it hardly affects the cost of 3D printing, which enables the production of the designs with better optimization using high property materials, high performance property materials. In that aspect, the additional cost it would incur based on the complexity of the design. Huge initial investment is required. So what are the challenges in 3D printing? Adapting 3D printing in mechanical engineering that involves a significant investment in high quality printers and corresponding associated equipments or machineries. Limited material selection. Although there are wide range of available materials which are in abundance in this universe, but still it is limited compared to traditional manufacturing process. Then post-processing. Many 3D printed parts in mechanical engineering require extensively post-processing to check whether the desired surface quality and dimension accuracy of the prototype has achieved or not. Next challenge, technical limitations. So the ability to print the complex structure, there might be some technical limitations on the size, build size of the component, and also the resolution of the objects to be manufactured. Then quality control and standardization. Ensuring high consistent quality in developing the parts, and we should able to follow as per the industry standards. So these are the basic challenges in 3D printing technology. Then last one, scalability. So although 3D printing is ideal for prototyping development and small scale production in mechanical engineering, so mass production remains a bigger challenge. So how much to produce depending on the external demand. So we need to better forecast and prepare the model accordingly. What are the common materials used in 3D printing? So plastics, metal, resins, even composites like carbon fiber, these are the things that are widely available. Among all, plastics are the most wide common options for developing a model using 3D printing machines for various applications. Even sometimes metals like stainless steel, titanium, and aluminum for high strength and durability purpose, these materials are preferred. What are the latest emerging trends in 3D printing? AI-driven design. So using artificial intelligence, so we can able to optimize the design according to the perception of user with the help of the 3D printing machine by somehow minimizing the material usage and maximizing the performance much far better compared to the conventional technology. Then we can go for large scale additive manufacturing under mass production, developing large scalable 3D printers for applications like civil construction and aerospace industries. To identify the demand, the current demand in various sectors and develop a mass production approach for large scale application. So now we will see a small working demo of 3D printing machine.
This is a 3D printer. It takes three-dimensional models saved on your computer and physically creates them right before your eyes. 3D printers are both fascinating and complex. Each year, the technology gets better and better. In this video, I'd like to walk you through one of these machines to show how it works. My name's Jared. I create 3D animations to show and explain how things work. Hit the subscribe button to be notified about future videos just like this one. This video is sponsored by Bambu Lab. In science fiction, they sometimes have this device called a replicator. You can ask it to make almost any object, and it somehow materializes right in front of you. Today, we don't have replicators, but the 3D printer is starting to do some of the same things. It doesn't happen instantaneously, but it's still quite impressive at what it can do. 3D printing is a type of additive manufacturing. You start with nothing and then add materials layer by layer until it's complete. Compare that to subtractive manufacturing. Start with a block of material such as metal, and you remove parts from it to form the final product. Notice all the excess waste. With additive manufacturing, there is much less waste of materials. This is an advantage to 3D printing.
Gmail எப்படி ஒரு மெயில ஸ்பாம் டிடெக்ட் பண்ணுதுன்னு தெரியுமா? மஷின் லேர்னிங்க்கும் இதுக்கும் பெரிய சம்பந்தம் இருக்குங்க.
Yes, it's true. A 3D printer can be used to create all sorts of toys, minifigures, movie props, you name it. But keep in mind that a 3D printer can be used to create objects that have a more practical use. A lid holder for your kitchen, zip ties, adjustable supports for just about anything, a Wi-Fi QR code sign, and even a customized broom holder. Very useful for your kitchen. You can even 3D print accessories for your 3D printer. You're only limited here by your imagination. In the real world, there are some other interesting uses. 3D printed food, yes, it really is edible. 3D printed clothes, and 3D printed prosthetics for those that need replacement body parts. Large-scale companies are using 3D printing to manufacture products because it's less expensive and quicker to produce. Companies like SpaceX are literally 3D printing parts of their rockets. NASA is hoping to use 3D printing to create items when astronauts are far from home. This means they don't have to bring as many tools and spare parts into space. And there are even 3D printed houses. Instead of plastic, they are made with a special concrete-like material. And yes, people actually live in them. It looks quite nice if you ask me. There are different types of 3D printing. The most common one, and the one used in this video, is called fused deposition modeling, or FDM. It takes a long strand of filament. This is usually some form of plastic, but it really depends on what you're printing. Then it melts it into a specific pattern to... For this video, we're going to walk through the A1 face. Let's take a closer look at the A1. This part is called the gantry. Your 3D object will be printed on a metallic build plate. This can be removed so that it can be washed or even replaced with a different one. It's held on by strong magnets directly underneath. There is a touch screen right here to control the 3D printer, but you can also control it from another device such as a desktop computer or even your mobile phone. At the top of the machine, there is a plastic support arm that holds the filament spool. The end of the filament is hand-fed into the tube opening shown here. Then through the plastic tube, which connects all the way down to the tool head. Inside, the filament will be melted and come out the very bottom. Inside the tool head, there is a stepper motor, which will spin to pull the filament through to where it is melted. Now, in a regular electric motor, it uses electricity and magnetism to continuously spin in one direction. A stepper motor is different because it can be precisely positioned and will stay there until instructed to move again. There is another stepper motor over here. When this spins, it moves the belt that goes all the way across here. Moving the belt causes the tool head to move left and right. This bar is called the X-axis linear rail. There are two threaded rods on each side. You can actually see them if you move in far enough. When these spin, the rail and the tool head move up or down. They call these the Z-axis linear rails. This means the tool head can only move in 2 dimensions. But this is a 3-dimensional printer. For the third dimension, the build plate moves back and forth on the y-axis. Down below, there is another stepper motor that spins another belt. This is what moves the build plate back and forth. 3 dimensions of movement allows the printer to create your 3D models layer by layer. There is a camera up here to take images of the objects as they are built. You can even make a time-lapse video, which is really fun to watch afterwards. 3D printing can be as short as just a few minutes, or as long as several hours, or even a day or two, if your object is complex enough. The area inside of this imaginary box, this is called the build volume. You can only create 3D objects that fit inside of the build volume. If you want to print something bigger or maybe more complex with more integrated parts, you can still do that. You just have to find a way to print it in several different pieces. 3D printers from Bambu Lab come with a handful of 3D models ready to print and built into the 3D printer for easy access.
எதை வேணும்னாலும் சாப்பிடாத, ஏதாவது டேஸ்டியா சாப்பிடு. Sneakers, peanut brownie, ஏதாவது டேஸ்டியா சாப்பிடு.
Can mathematics fix fashion's growing waste crisis? Can you grow your own farm in a
You can even use 3D and many distinct layers that can be 3D printed. For us, you don't need to understand this G-code. You pulse the filament through. The part at the bottom, this is called the printer poop. Yes, the printer has got to put it somewhere. Many people actually 3D print a special container right before it actually starts printing, and it usually draws a few lines at the front to make sure it's still flowing correctly. At the back of the build plate is the nozzle part is called the infill. You can make this part completely self. Let's take a look at this 3D model. Those supports. When it's done printing, the supports, this connects directly to the A1 printer. Type and color of filament. It's to switch colors. The tool head moves over to the other side to get rid of this extra filament. Let's take a closer look at what happens. The A1 is an inch open. There's no walls enclosing this area. That makes it impossible to control the temperature and humidity through the glass door in the front to access the inside. Up at the very top is the tool head. It can handle higher temperature. The X1 carbon provides a lot more stability. On the side, there is an improved camera that will monitor the rest. This one is just called the AMS. It has a lid to fully enclose your filament spools. This keeps out the moisture, allowing for a higher quality of 3D prints. If you're interested in a 3D printer similar to the one shown in this video,
So once again, welcome back to the PPT mode presentation. So I'm going to end the lecture. So in conclusion, what I mean to say that 3D printing is nothing but reshaping the landscape of mechanical engineering by offering a more powerful toolkit for better innovation and efficiency in future. So with this conclusion, I thank each and every one of you. And these are some of the works which I did in the past, 3D printing and its importance in engineering literature review. This paper has been published in IC Scan conference in the year 2020. And in addition to that, another annexure paper, application of additive manufacturing for automobile spare parts, an extended review. So these are some of the works which I did in the past. So with this information, I once again thank all the members. So we will meet in another different topic. So thank you once again.